So we'll talk a little bit about some new technologies we've been working with to monitor TCs in their environments. One of those programs is under the Sensing Hazards with Operational Unmanned Technology. That was the SHOUT program. And it was really a collaboration between NOAA UAS, AOML, NASA, and actually several other federal and university groups. One of the main objectives was to demonstrate a UAS concept of operations, and we accomplished that through data impact studies. We conducted OSEs where we're looking at model impacts from actual UAS data, as well as OSCEs where we're looking at those impacts from simulated UAS data. And there's a photo of the Global Hawk, really the workhorse of that SHOUT program. We had 3 field campaigns. We kicked off in 2015 with Hurricanes 2015, 3 missions into 2 tropical cyclones. Moved to El Nino rapid response in winter 2016. We had 3 missions targeting 2 high impact weather events on the West Coast. And then finally, Hurricane Rapid Response, kind of the grand finale for hurricanes in 2016, where we had 9 missions into 4 TCs. If you look at the Global Hawk aircraft, it has a duration of about 24 hours. And with a flight level of 55 to 65,000 feet, it spends a lot of its time in the lower stratosphere. It has a range of 8 to 10,000 nautical miles. So we have even 6 hours of on-station time in the Eastern Atlantic. The equivalent on-station time for the manned aircraft is much further to the west. Finally, a payload capability of 1,500 plus pounds. Some of the instrumentation we were carrying, GPS Dropsondes, we were quality controlling those and sending them to the GTS in real time so they could be used at forecast centers like the Hurricane Center or EMC. And we had a capability of 90 Dropsondes per flight. We also had the Hamster microwave sounder, where we're getting 3D temperature, water vapor, cloud liquid water in 25 channels. Here we're picking up on the warm core development of Hermine as it was approaching the west coast of Florida. And finally, the high RAP Doppler radar, giving us 3D winds and precipitation. In this case, we're seeing radar reflectivity and winds down at 1 kilometer for Matthew as it was approaching, at this time, the east coast of Florida. If you were to drop a dropsonde from these different manned aircraft and drones, here are the SKU-T diagrams that you would get. So these are analyses of temperature, moisture, the winds. So one thing to take away with a high altitude UAS like the Global Hawk is you start seeing things like the tropopause level, the full depth of the outflow layer associated with the storm, the full depth of a dry air intrusion that was lurking around the west side of the storm. So certainly all of these aircraft have their advantages and disadvantages. A big advantage of a high altitude drone like a Global Hawk is you're able to observe the full depth of the tropical cyclone atmosphere. We also looked at the impact of those dropsondes on GFS track forecasts. So the takeaway here is the red line. We saw improvements in skill of up to 15% with those dropsondes, particularly at 72 and 96 hours. We're doing retrospectives with the FV3 version of GFS. Hopefully those results will be out soon. We also developed some techniques for targeting dropsondes to improve model forecasts, particularly using ensemble model information to really get at 2 questions. First, where is there uncertainty in the model forecast? This is the approach used by the Hurricane Center to draw their G-force and optic surveillance mission tracks. But also this second question of where is the model more or less sensitive to your observations? So it answers this bigger question of where do you sample and will the model be sensitive to your added data? Thinking bigger bang for the buck. It's a nice example of R2O where this research during SHOUT has transitioned to a JHT project that's currently being evaluated by the Hurricane Center and was used quite a bit actually this past hurricane season. And then finally, the TROPICS satellite mission. It's a long acronym. It's essentially a constellation of smallsats scheduled for launch in 2022. Should consist of 6 satellites. And one of the big advantages is going to be rapid refresh microwave observation. So it's going to be temperature, moisture, and precipitation. We'll have 8 temperature channels from 91 to 118 gigahertz and 5 water vapor channels from 91 to 205. So this is a nice example of trying to get at the data early. So we've got a TROPICS applications workshop set up for this coming winter. And we want to get users start thinking about using this data before the satellites even get launched. I'll just point you to that poster that's going to be tomorrow. There's a lot more